Hello, my name is John Amabile. Welcome to the Chapter 6 video for my book, Changing the World, the for-profit plan to mine asteroids and terraform 2 planets in 1 human lifetime. In this chapter, I'll be discussing atomic ice mining. So the basic idea behind atomic ice mining is that we use a fusion device, which is a hydrogen bomb, but has been rendered militarily inert. So there's a ton of different ways to do this, which I discuss in my book. But basically, it's something that's not useful for the military to use. We can make it not even possible to detonate it within 100 million miles of Earth. We could only assemble it once it's, past the main belt. A bunch of different options here. But in other case, we take in my plan, a 1,500 megaton fusion device. We designed weapons that were 1,000 megatons during the Cold War. But obviously, because of the small size of the Earth, a weapon of that size would be ridiculous, and these systems were never built. But during the Castle Bravo test, we did confirm that even a slight addition of lithium to a hydrogen device would create an enormous amount of yield. So this is not, by no stretch of the imagination, is this science fiction. All of this math very much worked out. The Soviets detonated a 70 megaton bomb with technology vastly inferior to ours in 1962. So anyway, we have 13,000 plutonium bomb cores in storage, which is the expensive part of an atomic bomb. Again, the Cold War was kind of called off, so those systems were not placed into functional weapons, but after we made plutonium, there's nothing else to do with plutonium, so it's just sitting in Department of Defense warehouses even today. And it's very likely the Russians have at least 2 times as many plutonium bomb cores, simply because their weapons degrade faster, so they have to produce more plutonium at a higher rate. Also, they produced about 2 times as many atomic weapons as we did during the Cold War. The exact numbers are sketchy, but it's reasonable to think that they have far more of these than we do. With smaller numbers being possessed by France, England, and China. So in either case, the way that we do this, specifically to my plan, we make 11,000 fusion devices, each one with a 1,500 megaton yield. Each of these devices would weigh about 700 tons, of which about 1 or 2 tons would be the actual fission reactor, which I call the fission igniter, which is about 2 tons. And then the other 698 tons would basically just be concentric layers of lithium and steel. So you have the initial reaction, which creates density and heat, and that kind of sets off a secondary layer, which is bigger, which sets off a tertiary layer, which is bigger still. And then you just do as many layers as you need to. I think 4 or 5 layers would be sufficient to give you 1,000 megatons. I don't have the specs for a 1,000 megaton bomb, to be clear, but it was announced by the bomb technicians that 1,000 megaton bombs were designed in the 60s, and the U.S. government still has the designs for those systems. So we divide this number in half, so we have, in my plan, 11,000 fusion devices. We break off 5,500 pieces of asteroids, and each of these pieces would be 60 kilometers across, so very, very big. I actually call these megapilli in my book, because anything above the size of 1 kilometer, we use very different math, it's a very different process. So we remove these 5,500 pieces. Most of them would come from the asteroid Ceres. We know that 25% of Ceres is ice, which is a huge chunk of what Venus needs. The remainder we would take either from other asteroids or comets in the main belt, or from Saturn's moon, Iapetus, which we know is more than big enough for all the ice on Venus and Mars. So anyway, 5,500 of these objects would be removed with a fusion device. We would cut the sides out with ice blade rigs, basically just an ice core machine, just designed to work on an industrial scale. We would put the hydrogen device at the very bottom of the object, and when it detonates, because the sides are cut out and the center is not, there is no place for that energy to go except in the direction that we have pointed it. The same idea as a gun. You have gunpowder, it detonates. Because the barrel constricts the flow of energy to one specific spot, all of the energy is rushed out of that one spot, and that gives you a bullet going out of a gun at a controllable velocity. We'll basically be doing the same thing, except with what I call megapilli, so a huge chunk of ice detonated, thrown out at a precise speed and trajectory. Of course, we may not be able to do this perfectly, so we'll be using what I call Protoballista 2s. So by now, the mining effort, which I've discussed in previous chapters, will be going in full swing. We'll have plenty of slag, tons of iron and nickel that we're not bringing back to Earth, and we can use these to build even larger ships in space, so something the size of a a Carnival cruise liner in space that might have a 100 megawatt nuclear thermal rocket in it, and could, really alter the course of something that was 50 kilometers across, or 100 ships of that size. So the proto-ballistas are very small, kind of the size of a bicycle. A ballista is much larger, maybe the size of a full-size van. And then a ballista 2 would be the size of, a ship on Earth, like a Navy destroyer, maybe even a Navy aircraft carrier. There's really no size limit because we'll be having billions of tons of slag from asteroid mining at this time. So anyway, we send these objects toward Mars. We use nuclear thermal rockets to tweak those trajectories and ensure they're on course. Now, even the ones that are going to Venus will first go to Mars because it's in Mars orbit that they'll perform a gravity assist and they'll gain more speed and be sent to Venus faster that way. Basically, 11,000 of the objects will go, 5,500 of the objects will go to Mars. The Martian gravity will turn it and accelerate it and send it to Venus. And maybe the last 5 or 10 objects will go to Mars. I'll address Mars in a different chapter. Now, to be clear, it's 5,500 objects and it's 11,000 fusion devices, and that's because we use one object to remove them from the asteroid. Then, just before they come down on Venus, we place another fusion device in the center after we've cut blast tunnels out of that object, and we detonate it so that it breaks into pieces and falls into Venus in meltable chunks instead of crashing into one solid chunk and damaging the mantle of the planet. Well, anyway, I'll go into the specifics of Mars and Venus in a later chapter, but thank you for joining me. If you have any questions, please post them to my YouTube channel, or feel free to send me an email as well. Take care.